course. And just two little things on penguins that we have seen. Yesterday, a lot of you saw the white penguin. You had your continental landing. We're ticking the boxes, right? Gen 2, and the delis, tick, tick, continent, tick, tabular iceberg, tick, and there's one more to tick tomorrow. There you go. Anyway, they even have on their badge these leucistic penguin. Albino, liquistic, blondie, what is all this? So this is some pigmentation anomalies that you see in the animal world. This one, for example, this king, some of these pictures belong to Will, and this one got it all wrong. Look, more yellow than it should, a lot of white there, so what's going on there? So these are the leucistic penguins. A true albino, in this case, a crow here, shows no pigment whatsoever. You can see the blood cells through their eye. So what we saw yesterday was not an albino, right? These are other examples of leucism in other animals, giraffe, an owl there. And these are the penguins here. They can also occur on the adelis, 1 in 40,000, 1 in 20,000 on the gentus. And this is an adelie here. You can see the pattern, of course, right? And you see the beak and the eye have the proper color. And that's our friend from yesterday. We'll serve the bait, if it's a female or a male. We were all hoping to see, we're standing there, group after group. Oh, is there any mating, any action? Who's got the footprints on their back? And then we did not succeed. So, but we do know that that individual bird has been going there for at least 10 years, breeding, because we've seen chicks. The chicks are normal. We had the feeling with Brent that the partner this year was a different one from last year. Can't be 100% sure. There you go, another deli here. And the opposite is melanistic, or melanism, in which you have more deposition of the dark pigments, the melanin, so they look darker, right? Look at this egret here. Look at melanistic gentoo chick. And this was, once again, king penguins that got it wrong there. But you can have it in mammals also. Squirrel here, and perhaps the best known melanistic animal is like a black panther. You can also have jaguars, in which the black spots grow more, and they become all white. If there's more yellow than it should, it's called xanthism. This one has a bit of that, and that's not gray hair or dandruff. That is some pigmentation problems. And look at these, South Georgia, we have these Antarctic fur seals, these blondie types here. So it is not unique to penguins. But most important now, and just to finish off the night, we've been hearing about the diet of penguins. Rachel explained about the importance of krill. Iggy keeps mentioning the guanomatics and the guano this, and we all laugh, and the guano, and I see you walking around and stuff like that. But, there's science to be learned about all this. So this is a chick here begging for food. You can see there's a lot of food coming in, and they have these kind of a very sharp tongue and palate in order not to lose anything. And when they're adults, they're going out for krill, some of them fish, and they get fed. There's a lot of energy being put into these chicks that require to build up a lot of fat, and later burn that fat to get proper feathers when they molt down into feathers and are ready at the end of the season at the summer to go hit the ocean. And what comes in must come out. And, we've seen this, the nest there. Red guano usually means a lot of krill in the diet. White guano means a bit more of fish. This is an ice fish from Antarctica. That's krill. The fluoride of the exoskeleton of the krill is not digested, and they get rid of that. But what catches my attention is the way they poo. If you're very sensitive, you could leave the room now. I won't take it personally. The door is there, and then it will be ready soon. If you can bear with me a few more minutes, you will learn a few more things. So first of all, they poo in these lines. Yeah, it's full of poo. Do you want the poo in your nest? No, of course not. So you have to, adapt and evolve in such a way that the poo is going to go somewhere else. In some occasions to your neighbor, but that's not your problem. In other words, it's their problem. You can't have the poo in your eggs because you're taking your eggs there, taking good care of them, fighting for those pebbles, keeping it high above ground, above the mud, above the guano. Mud is a euphemism for one in Antarctica, as Trevor said, and the snow. So there you go. That's all the poo and on the nest. Keep moving here. Sorry. When the chicks grow, which is not now, later, you might notice that they position themselves from a very young age in a very peculiar way with their cloacas, to use a proper word. A cloaca is the combination of the urinary and the excretory system in birds, and a little hole where number 1 and number 2 come together. That's why when you get blessed, it's a bit bushy and you can't really tell what it is. That's 1 and 2 coming off together. And off they go, boom, out of the nest, because the chicks already know that. Now, when I said the neighbor, you might have seen a penguin with a white streak on its back. That is not a pigmentation aberration. That is a very inconsiderate neighbor. And sometimes, according to the fluidity of the matter, obviously the more liquid thing will evaporate and go away, but other sort of lumpy things will remain, like in this case here. They don't seem to matter much, eh? They don't seem to bother. There you go. Anyway, this one is the culprit, I believe. Now, all these is very interesting. You have noticed in the expedition team there are scientists. I'm not one of them, but I listen with all respect and I learn a lot from them. And then science is usually pressed with significant matters in solving the mysteries of the universe. And penguin poo is no exception. How do they poo? I mean, can they aim? Are they accurate? Is it happen at will? Is it voluntarily or not? How do you explain? How long can they reach? So obviously some scientists have taken the work in understanding the pressures produced when penguins poo, calculations on avian defecation. So of course, there's an abstract, and a theory, hypothesis, and a conclusion, like in any scientific work. The first thing you do if you're a scientist, you go to the evidence, you try to replicate what nature does naturally, and you build yourself a model. So there's a little model there of your penguin. Obviously, you also need a model of the nest. You have to establish an average height of the nest and an average height of your penguin. In this case, 60 centimeters, elevated 5 centimeters above the ground, and then the elevation of the quokka over the ground is 20 centimeters, and you establish the diameter of the quokka, which will vary depending on the species. In this case, we also once again reach a mean diameter of quokka of 8 millimeters, just under 1 centimeter. Now, after some very rigorous research, you come out with obviously complex graphs and so on, and many very important conclusions are reached. For example, the viscosity, because the viscosity of this fecal matter will affect the reach stage. In this case, it's been notified here that the viscosity is very similar to olive oil. In this end, you have water, and in this other end, toothpaste. So somewhere in the middle is the average viscosity of penguin poo. These lines here show you the different diameters of the different quokkas of different species, but for this study we will just remain with the average and apply it to all species, right? Move on, back to our model there, and we reach a very important conclusion. The average was 40 centimeters of reach, which is mighty good, but in some cases it was almost 1 meter. Imagine this. Please don't think all these to your own species, because that would not going to be very nice. 90 centimeters of reach. That's very interesting. Now, the research doesn't end here, and there are pressing questions which need to be solved and remain unanswered. Can they aim? Yes, they can. Can they regulate rectal pressure at will in order to have more or less reach? Do they participate in pooping competition? We don't know. Maybe they do it at night, and IATA does not allow us to go on land at night, so we don't know what's happening there, even though there's daylight. Maybe they gather and they have, some hierarchy. Do they consider wind speed and direction before discharging? Imagine with the katabatic winds of Antarctica, if you go wind on, the mess is not going to your neighbor, it's going to yourself. So you must take that into account. And last but not least, are pooping strategies learned, inherited, or are they taught, generation after generation? So all these remain unanswered, and my conclusion is that the leucistic penguin poops in a white matter. Thank you very much. Bon appetit, eh? I forgot to say bon appetit. Just everything right.
Okay.